Hey everyone, we're going to be looking at Unit 9.4, and the goal of this lesson is going to be to talk about how to find parallel and perpendicular lines, mostly with linear equations, but we'll look at, like, the first example will just be based on three-dimensional shape and space. So if you look at the definitions here, they talk a little bit about parallel and skew lines. So skew lines are any type of line that aren't parallel, but they don't touch. So if you look at the line AB and CD, if you look at this line right here and this line, it looks like they almost touch, but they don't, because AB is about, 4 or 5 inches to the left, so that line passes behind the other line. And then anything with parallel, the whole word coplanar means that they share a plane. So imagine a two-dimensional shape, a piece of paper basically, and then you had two lines on that plane that are going the same direction. So you can place a piece of paper between any two parallel lines, hypothetically speaking. So there's some different definitions. We're going to look at a couple of these in the examples. So like AB and CD, okay? So like AB is this segment right here, and CD is this segment. Well, they don't share a plane, okay? And they don't intersect. So like in this case, these would be skew lines for A. If we look at another one, EF and DG, well, you can see that EF is going vertical and DG is going vertical, so like that one would be parallel. And if we look at AF and EF, AF does make contact with EF. So in that case, if this was a cube rectangle prism, it looks like it would be parallel, but we'll circle intersect for that one. And then CG and AH. So CG is a diagonal line, and AH is kind of a horizontal line. So like those two don't intersect, so they would be called skew. So again, this is dealing with a three-dimensional shape. Now we're going to look at and talk about parallel and perpendicular with coordinate geometry. So if you look at the next set of questions, okay, and the big goal of this, and with all of these, is make sure that you get y by itself. That's kind of the biggest thing, because we want that slope. We want to know what that slope is, and that's got to be with x, and it has to have a y by itself. So if you look at A, notice we don't have y by itself with this one, but we can get it by itself by dividing by -3. Okay. So if I divide each of these by -3, 3 divided by -3 is -1. 9 divided by -3 is -3. So like in this case, the slope's -1, and the one from above has y by itself, so like those are parallel. If you look at B, for each of those we have to get y by itself. So I'm going to write down each equation. And I'm going to subtract the x from on each side. So I'm going to subtract 3x. So then we have 5y equals -3x plus 15. And then we divide by 5. So I'm going to kind of hold off on doing all the work for this, but my slope for this one will be -3/5, because that y-intercept really doesn't matter. And then for the other one, I subtract the 5x on both sides. And we have 3y equals -5x plus 15. And then divide by 3. And again, I don't need to show everything, but I will have for the slope, have this fraction -5/3. In this case, these are not parallel, because the slopes are not the same. So when we have those parallel lines, just remember we need to have the same exact slope. Same sign, same fraction, same everything. So now we're going to look at a perpendicular example. So if you go to the back of this page, And like it says, they're at what's called a negative reciprocal. So example of that would be perpendicular. Here's a symbol for perpendicular. So if we had a slope, let's say we had a slope of 2/3, and then the other slope was -3/2, those would be perpendicular. Now if we look at A, this one's great, has y by itself already. There's an imaginary 1 here. In this case we have -1 and 1. If you have a whole number, you can always put each one over 1. So the question is, are these two perpendicular? And they are, because if you flip the numbers and change the sign, you go from -1/1 to +1/1. And then we're going to look at C. And then with C, we have a slope of -3 for the top one, which is -3/1. And then if we simplify this, we get +3. So like in this case, these two are not perpendicular because the fraction wasn't flipped. And if you want to try the middle one, feel free to go ahead and try that one also. So now let's move on. Now we're going to talk about examples where you have an equation and you're trying to figure out what line would be parallel or perpendicular to it. Okay. So you have to make sure that you determine whether they want parallel or perpendicular. So like in this case, for the first one, for our first equation, -7x minus 5, well, we know that the slope is -7. Now with our new equation, we need to make sure we use that same slope. So we're going to use what's called the point slope form, which is this equation. And we're going to be filling in numbers for y1, m, and x1. So our slope will go in for m, and then for x1 and y1, we'll have 1 and 3. So when I write this out, I have y minus 3 equals -7 parentheses x minus 1. And if either of those numbers were negative, we would have to change those signs, the signs here and here, to a plus sign. So to get y by itself, because they want an equation, you distribute, you get -7x plus 7. Same thing like we talked before, get y by itself, and you can add 3 to each of the numbers on each side, giving us y by itself and then -7x plus 10. And if you have a graphing calculator, you can check and just make sure that this point, 1, 3, is on that table. Now the other one's talking about the equation of a perpendicular line. So we know our slope is 1/4, but if we want a perpendicular slope, that's going to have to be -4/1, which would just end up being -4. Now I'm going to do the same formula. I have a x1 and y1 values. So I'm going to do y minus, in this case 4, equals -4 parentheses x, and I'm going to change that sign to a positive because it's a -12. So same thing like we just did, distribute it, and then I'm going to add that 4 to each term. You get y equals -4x minus 44. And again, you could take the graphing calculator, put that equation in, and just check and make sure that point is on that equation. Okay. So let me know if you need help. Also, make sure you write the equations down on the top of the paper to help you.